Hello students, welcome back. We went through sections 2, 3, and 4, but all those are arguably just preparatory steps for section 5. In section 2, we went through some basic ideas. Sections 3 and 4 are really preparations. In section 3, we went through how to work with this standard normal table, forward and backward. In section 4, we went through how to utilize the formula number 1, z equals x minus mu over sigma, or end minus center over st. Now, let's go to some empirical problems that we'll have to solve using those ideas. Here's the first problem. The intelligence quotient scores are normally distributed with a mean of about 100 and a standard deviation of about 16. If one person is selected at random, what is the probability that the selected person's IQ is between 90 and 125? All right. Let's prepare some space for normal pictures. Okay, that's gotta be enough, and let's go to the drawing mode. Okay, that's the kind of situation we are in. We want a normal picture like this, centered at 100. And then this is 125. And here's 90. And then between 90 and 125. Now, does it make sense? And then, how do we actually get it? Well, one strategy is to do this. And this is 125. And then find out everything to the left. And subtract this probability. Does it make sense? This middle area is this big area, everything less than 125 minus less than 90 only. So big minus small, and then you're going to get the middle part. Make sense? I told you we are going to do a lot of geometry problems, so draw the picture. Drawing the picture is very, very, very important. All right. Let's rewrite this in an algebraic expression. Let me try to do that because I don't want to lose this picture. So this probability that x is between 90 and 125, that's basically the same as x is less than 125 minus x is less than 90, isn't it? So this one corresponds to the first picture, and this one corresponds to the second picture. And this one is associated to this end of 90, so that'll give me appropriate z-score. And this one is associated to this 125, that's the end, so that'll give me appropriate z-score too. So associated z-score, and then associated z-score. You'll have to find out these two z-scores, and then two probabilities, and subtract one from the other. All right, makes sense? Is that a good roadmap? All right, I hope everybody understood. And let's get out of this drawing mode. Okay, we are back. And the solution looks like this. We want this probability centered at 100 between 90 and 125. And then we have two n's, so we need two z-scores. N minus N2 over ST for the first n, 90 minus 100 over 16, I get z-square of negative 165. For the other one here, 125 minus 100 over 16, I have 1.56. So what do you get as a probability? Less than negative 0.625. Well, you'll have to look up the z-table. Okay, let's go ahead and look up the z-table. Oops, sorry about that. Z-table, all right. Negative 0.625. 0.625. Negative 0.6 is here. And 25, let's see. Let's go to the, so negative 0.6 and 0, 1, 2 column and 3 column. So this is the probability associated to negative 0.62, and this one is associated to negative 0.63. I'm gonna need something in the middle because I have negative 0.625. Somewhere in the middle between 0.2676 and 0.2643, maybe about 0.266 something, 0.265 something. That's my estimation. Or you can use either this one or that one. I don't actually mind because it's approximation anyway. But 0.265 something, that's what I would expect here. So let's go back to the problem. 0.265 something. Yeah. That's what I got from this left-hand side. And then we can do the same thing from the right-hand side. 1.5625, okay, look up the table, close to 1.56, and do your computation. You're going to get something close to this. By the way, this number and that number are coming from Mathematical's computation, so far more accurate than the rough estimation we did with normal table. Either way, it's going to be okay. In any case, subtract one from the other, then we get, yeah, this kind of probability. Anything reasonable will be okay if I'm the grader. If you end up with this kind of problem with MyMATLAB, and then if you do everything right, and then it is simply the system is counting you wrong, then that means the problem is not very good. If you encounter something like that, either by computer grader, MyMATLAB, WebAssign, or Alex, whatever, just let me know, and I'll just record those and then give you appropriate points back at the end of the semester, because there's so many of those out there. So manually changing all will take too much time, actually. I mean, I've been having the unending problem with this computer grading. So I cannot manually change everything each time that becomes a problem. Let's see, do we have enough problem for another? Maybe. Here's an inverse computation problem. The intelligence quotient scores are normally distributed with mean of 100 and standard deviation of 16, approximately speaking, and find the 33rd percentile. So basically you draw a normal picture and normal picture, and then this is 1/3, 33%. So what do? Look up the z-table and look up the z-score for 0.33. And no, not this one, 0.33, so I have to go up further. 0.33, okay, right here. Negative 0.4, 0, 1, 2, 3, 4, negative 0.44. Negative 0.44. So that's my z-score. Negative 0.44. Well, I used Mathematica, so I got 0.439913. But if you look up the z-table, then you're going to get 0.44. And that's my z-value. So this is negative 0.44. So we are getting, so z is x minus mu over sigma, and that's approximately equal to, and nothing is accurate here, so approximately everywhere, and negative 0.44, and basically you're looking for the solution of this equation. Not bad at all. Flip this to the other side and flip that to the other side, and you're going to get this computation. You're going to get about 92.96, about 93. Okay, we went through a couple of problems like these, forward direction and backward direction, utilizing both the z-score and also the z-table. Okay, here's another problem, and by the way, do you recognize this problem? It's the very same as the motivating problem that we went through. No, we didn't actually go through. I just used it here as a motivational problem. According to CDC, the height of 18-month-old American girls is normally distributed with a mean of 80.2 centimeters and a standard deviation of 2.70 centimeters approximately. Estimate the percentages of 18-month-old girls whose height is shorter than 75 centimeters, taller than 82 centimeters, and between 75 and 82. Basically, I'm asking you to do this. Shorter than 75, taller than 82, and in the middle. How would you do that? Well, it's basically three problems. Z-score for this, and then look up the table. Z-score for that, and look up the table, and some further work. And 2 z-scores get appropriate area computation. Good luck. The next problem. Find the first quartile and the third quartile. First quartile, okay, here this area is 1/4, 0.25. Look up the z-score associated to 0.25, the best estimation, and set up appropriate equation to find that x value. How about this one? Well, setting up the same equation, x minus mu over sigma, so basically x minus mu over 16 is approximately equal to, well, some number which will come from the z-table, and then solve this, you're going to get the x value. Again, good luck. One more problem left, but I'll do this in a separate video, not because it's really long or difficult, but I regard it a little bit less important, so a lot of students may want to skip that video. So, right, except for that last problem, section 5 is complete.